Let's talk about your kidney. Let's start with the kidneys. We are actually going to do a whole chapter on the kidneys. I love the kidneys. The nephron of the kidney is maybe one of the most fascinating things going on in your body. But good news for you, we only have to talk a little bit about your kidneys. Your kidneys' role in producing 3 hormones. So it will make a form of vitamin D. It will increase your calcium absorption in your intestines, and it will inhibit calcium loss in urine because your kidneys are all about urine. So it does, one of the things, the main things it does is it looks at your vitamin D, right? This is crazy cool that your kidneys support so much of your body. I love the kidneys. So, your skin is going to activate that vitamin D. Your vitamin D is going to tell your liver, which will tell your kidneys to go ahead and release the calcium. So it really is important in calcium absorption and the activated form of vitamin D. It also secretes renin. What is renin? What is angiotensinogen and angiotensin 1? And that is converted to angiotensin 2, which constricts blood vessels and raises blood pressure. Okay, just to walk us through the liver again, here's your kidney. Let's say you have a drop in blood pressure, a drop in fluid volume. Your kidney knows this because it is circulating your blood. It is filtering your blood, all of your blood, right? So it knows what's going on. So renin is released from the kidney. Okay, what is that going to do? That is going to take your angiotensinogen and make it into angiotensin 1. What is that going to do? Then you're going to have the ACE enzyme, right? And that is going to make angiotensin 2. Why do you care? Okay, because that is going to act on your adrenal gland again. Seriously? And that aldosterone, I can't say it at the moment, acts on the kidneys to simulate the reabsorption of salt and water in your kidneys. So it's like the renin, so a drop in blood pressure, which is a drop in fluid volume, okay, is actually going to go all the way around and look back on your kidneys, and it's also going to stimulate reabsorption of water. It's going to say, hey, we have a little bit of a drop in blood pressure here. There's not enough blood, so we're going to need to keep some of that. We're not going to need to send it back out of speed. We're going to need to reabsorb some of that. So FYI, let's not send it all out of pee. Let's reabsorb some salt. Let's reabsorb some water. What else is it going to do? What's crazy is your kidneys are going to send a signal all the way to your blood vessels to stimulate vasoconstriction, right? Vasodilation is bigger. Vasoconstriction. What in the world? What is that going to do? It's going to say, hey, we're a little low on blood volume. We got a low blood pressure. And we're going to need to conserve that. So we're going to need to constrict the blood vessels to keep all that blood in there. So what does that mean? That means your kidneys are controlling your blood pressure. Come on. That's cool. This is why I love the kidneys so much, right? This is why I actually just cannot get enough of the kidneys, because your literal kidney right here is angiotensinogen to angiotensin to angiotensin 2, basically controlling the constriction of your blood vessels. That's nuts. Very exciting. And that's why I love the secretion of renin, which is very exciting to me in terms of endocrine function. So you get to learn the things that I think are fun. That's just what we're doing. That's just how we're playing. Okay. Kidneys role also in erythropoietin. Yeah, it's exciting. Erythropoietin promotes the production of mature red blood cells. So also your kidney promotes red blood cells. It's 85% of your erythropoietin is controlled by your kidneys, because your kidneys are filtering your blood. So they know what's going on with your blood, and they're like, hey, we need the bone marrow to produce more red blood cells. And so also, if you need more red blood cells, you need to drink more water. So your kidneys are like, yeah, we're good. Drink more water, get more blood. So if your kidney gets this, hey, this is not great. We need some more red blood cells. We don't have enough oxygen. So your red blood cells I mean, your kidney will send a message to your bone marrow, and your bone marrow will make more red blood cells. And also, this is a lot related to your iron level is necessary as well for red blood cell production. So if you don't have enough iron, that's not going to matter what your kidneys say. Hypoxia-inducible factor is the degrading conditions of normal oxygen tension. So if you're not getting enough oxygen into your kidneys, they will send a message to make more red blood cells. That's freaking amazing. Your kidneys are amazing. Okay, here is this from your book, and they're just using words that I feel like we need a review of because I didn't teach you A&P 1, so I don't know if you know these words, and I needed a review of these words, so I'm just assuming that you could use a review of these words too. So look at this beautiful thing. We're going to come back to it when we go through each of these one at a time. Do you remember what osseous tissue is? Like osteoporosis? Right, it's your bones. Bone tissue secretes hormones. So your actual bones are like doing stuff. How crazy is that? Your bones regulate your energy metabolism and help inhibit weight gain and the development of type 2 diabetes. Yeah, I'm not even kidding, right? That's crazy, right? So your bones are involved in the endocrine function. What? Yeah, your bones are like, hey, it's getting hard in here to handle this weight, so we are gonna need to inhibit weight gain. Okay. Second one, natriuretic. I am not very good at saying this one. Natriuretic. Okay, what does that mean? This is related to your heart. Natriuretic hormone is a substance that promotes the excretion of sodium from the body, usually through urine. So we're back to the kidneys again, because who doesn't love to talk about the kidneys all day long? Me. I love the kidneys. Okay, so we have your heart secreting, basically promoting the excretion of salt from the body through urine. Your heart is saying, hey, your heart's basically increasing sodium excretion through urine to help reduce blood pressure. So your heart is like, listen, the blood pressure situation is out of control. We need to get some of the salt out of here. Can you not, with the fries or whatever salty thing you just ate, can we just get rid of it? Can we please just get rid of the sodium and increase urine production? And this will decrease the workload on the heart. And that makes sense. The heart's like, hey, let's lower the blood pressure. We got too much salt in here. Okay, next. Oh, I gotta move my face over here. Okay. Okay. So enteric, another word that I didn't know if you knew because I didn't teach it to you. So I just want to make sure that you know what all these words are. Enteric hormones coordinate appetite, food-seeking behaviors, intake, physical and chemical digestion, and nutrient absorption. This basically is how the brain and the intestines are connected. You know, they're like, oh, everything in your brain is related to your stomach. Well, that's actually true. Everything in your brain is sort of related to your stomach, or a lot of things going on. What I really found interesting here is you see where the GLPs, you hear a lot about the GLP-1s and GLP-2s and what's going on there. And sure, it is true. The GLP-1 is basically, satiation and the movement of your stomach muscles. So this is just a review of the digestive system. I don't know what you've gotten through. I don't know what you learned. So I want to make sure that we have all these things together, and how we are connecting the stomach and the small intestines. So there's about 10, there are 10 here. Gastrin, insulin, glycagon. You already know those because we just talked about them. The GLPs. You've got some pancreas, secretin over here, and these are all coordinating your digestion, and that is also an endocrine function of an additional tissue. And then what else I think is crazy, is the last two, which we're just going to talk about because, actually, I think adipose tissue was actually talked about up here somewhere. But these are pretty easy. They secrete leptin, which slows your appetite. And there's long been diet things that increase your leptin so that you're not so hungry. It makes you feel full. And last but not least is the placenta, which secretes estrogen and progesterone and regulates pregnancy. So that is this whole picture. I broke it down for you because I didn't know what words you knew and what you remembered because it's the beginning of the semester. Okay, let's talk about hormones. Again, hormones are not secreted at steady rates. We talked about this. They fluctuate, right? If you are a female, you understand the situation with the hormones and the estrogen and the progesterone. And men do it too, but they just don't always understand it as well. Some are secreted daily, like you have a daily circadian rhythm producing your melatonin, right? Some are monthly, women's ovarian cycle. And then there's another one I want to talk about. So these, let's go back. Some are just secreted daily, like a circadian rhythm. It's dark. Let's make some melatonin. Let's go to sleep. It's that time of the month, every 28 days, right? These are like sort of just on a cycle. These are under the influence of a stimuli. This is our friends having a feedback loop, because who doesn't love a feedback loop in A and P2? All of us. So exciting. Okay. You have really three types. You have neural stimuli. We already knew this, right? The stimulus is like, hey, I'm hungry or whatever. There's a stimulus from the nervous system that is telling your endocrine system to do something. Like, I'm cold. I'm getting chased by a bear, right? And all kinds of hormones are being dumped on our adrenal glands, right? Chased by a bear, neural stimulus. You understand that one. Hormonal stimulus. This is the release of hormones in response to other hormones. So your hypothalamus, right? Your hypothalamus releases hormones to Ant Pit to releasing hormones, which release hormones to thyroid releasing hormones. Yeah, I know it's crazy, but it's the loop we know. So hormonal stimuli is like releasing hormones from Ant Pit. Okay? Humoral stimuli refers to the release of hormones in response to changes in the bodies, like the body's fluids, such as your blood or your lymph nodes. So this is like your pancreas saying, hey, there's a ton of glucose. Glucose is high. Let's release, then the insulin is released, and then you're storing things as glycogen. Yes? Okay. So those are three types: neural, hormonal, humoral. Types of endocrine gland stimulus in pictures. The stimuli in pictures. Here's your humoral. So capillaries contain a low concentration of calcium, which stimulates your parathyroid glands. Remember these little guys on your thyroid? We're going to talk about them again one more time. And they are going to secrete parathyroid hormone, and it's going to increase blood calcium. You have neural stimulus. So we're going to go with the spinal cord sending a message to your medulla adrenal gland, and that's going to dump some epinephrine on your heart so you can run away from the bear. And our friend, the hypothalamus, stimulating the ant pit to secrete hormones that release the hormones to these guys. Thyroid stimulating hormones, adrenal stimulating hormones, other stimulating endocrine glands to secrete hormones. Yes. Okay. We talked about this, but never hurts to review. Hormones stimulate only cells with receptors. We are not just dumping hormones on your body and we're just willy-nilly, every cell in your body is going to respond to that. Nope, that's not what we're doing. We are dumping hormones sometimes into your glands when there are receptors to get that message. Okay? So receptors are molecules on your plasma membrane that turn on the metabolic pathway when the hormone binds to them. Okay? So we're not just dumping it in there and every cell is going nuts. You got to have a receptor, right? We are theoretically dumping thyroid stimulating hormone all over your capillaries, right? But the only cells that have receptors are your thyroid. So it only affects your thyroid. Yes? Okay. This target cell has a few thousand receptors for the hormone, not just one. So if one of them doesn't work, there's thousands on your thyroid to intercept the thyroid stimulating hormone. The receptor hormone interaction is very specific and usually happens only at saturation. Like if one rogue hormone goes and binds to one receptor, it's probably not going to turn anything on. There is a specific receptor for each hormone. And definition, saturated, are when all the receptor molecules are occupied by the hormone. So when all of the receptors have been saturated with their hormone, then something happens. Okay, so small stimulus, hormone. CAMP, we'll talk about CAMP. That activates enzymes. Remember, enzymes speed up the reaction but not used. That makes the metabolic product, and then you have an effect. Okay, so one hormone molecule can activate a bunch of other enzymes that keep going. Okay, so one hormone molecule makes CAMP, which is a cascade of chemical reactions, which activates more enzymes, which creates a metabolic product, which has a great effect. Okay? So we don't want to willy-nilly release hormones into our body for no reason. That's why there are so many checks and balances. So sometimes a very small stimulus can produce a very large effect. Case in point, my super fun, your eye has receptors, neural, but still, that in your peripheral vision, when there's dangly things, you freak out and you're dumping adrenaline on your heart. Okay? Insulin, all of these, a very small stimulus can have a very big effect and a very long effect, which is why they're regulated and which is what makes it different from the nervous system pathways. Hormone concentrations are typically fairly low in your blood. We're not, it's not like your blood is 10% thyroid stimulating hormone, right? They're very small, but it doesn't take very many of them to saturate their little receptors and cause a huge effect. And also, they tend to, through CAMP, activate enzymes that make a big old metabolic product, like a bunch of adrenaline that gets pumped on your heart, okay? Hormone interactions. Most cells are sensitive to more than one hormone, and they can exhibit interactive effects. There are three interactive effects. Synergistic, multiple hormones act together. So follicle-stimulating hormones and testosterone make sperm production. You have to have both to make sperm. So this is like synergistic. Both of them together make a thing. Permissive effects. One hormone enhances the response to a second later hormone. So estrogen prepares the uterus for the action of progesterone. That's a permissive effect. And you also have antagonistic effects. These are a lot of the things you see in feedback loops. One hormone opposes the action of another. It's like I just love talking about glucose. Insulin lowers blood glucose and glycogen raises it. So remember, those are the two enzymes. Insulin and glycagon are the enzymes making glycogen and glucose. Yes? Okay. Those are antagonistic effects. Hormone signals must be turned off when they have served their purpose. Most hormones are taken up and degraded by your liver and your kidneys and excreted in bile or urine. So this is how we know what's going on when we do a urine test, is we can tell what kind of hormones are happening in your body. I will say this again, when we do the kidneys, you very often don't need a blood test. We don't need your blood. We do need your urine though, because your urine can tell us a whole bunch and you just go pee in a cup and we can learn a bunch about you. The other thing is metabolic clearance rates. This is the rate of hormone removal from the blood, and this is just sort of a measure of how well your endocrine system is working. Also, hormones have half-lives. The time required to clear 50% of the hormone from the blood, the faster the metabolic clearance rate, the shorter the half-life. This is just telling us how long those hormones are in your blood. Stress. Stress upsets homeostasis. It threatens your physical and emotional well-being. These are things like injury, surgery, infection, intense pain, grief, depression, anger, or just generally being in college. So try and get a hold of the stress because it creates a bunch of endocrine hormones. General adaptation syndrome. This is a consistent way your body reacts to stress. Involves elevated levels of epinephrine and glucocorticoids, especially cortisol. So you have an alarm reaction like, oh shit, there's a bear or there's a spider in my peripheral vision and I don't like it. Initially your body is like, are we sure? And then at some point you freak out and then you're really tired afterwards, right? After you take an exam, you're extra tired because your body has been in a parasympathetic nerve response, but it's also dumped a bunch of hormones on your body and you are tired. General adaptation syndrome, otherwise known as the stress response. This is, again, just telling you what your stress response is. Your initial response, so your norepinephrine, your fight or flight, oh my gosh, there's a bear. After a few hours, your glycogen reserves are gone, but your brain still needs glucose, and that is what creates the exhaustion, the feeling of just, I cannot move. I took 2 tests today, and I went on a run, and I did a thing, and now I am exhausted. Your fat reserves are gone, your homeostasis is overwhelmed, and this can result in a rapid decline. I'm not sure, you're not going to die. if you take 2 tests and go to practice. But you need to be aware, and you need to make sure that you're having some carbohydrates and that you're learning how to calm down, because it is really important that you learn how to regulate these processes so that your body is not flooded with hormones and epinephrine. You can do this with strength training. This is it's developed from the British Medical Journal, and it again is just avoid overtraining and being like overstressed. Let's talk about paracrines. Paracrines are chemical messengers. They diffuse short distances and stimulate nearby cells. Histamines, nitric acid. Okay, so we're going to have 3 of these guys, okay? Paracrine signaling. This is to an adjacent cell. This is not when we are talking about ant pit, right? This is like to the one next door. So paracrines are very short. They're going from one to another. Important family of paracrines, derived from various acids. So here is some of the lipid soluble ones. These are the eicosanoids right here. They're lipid soluble, and they are cell membrane receptors, and they are mostly involved in your immune response. Oops. Autocrines. These stimulate themselves. Autocrines stimulate themselves. So it is here and it releases and then it absorbs back out in the receptor. And I know it sounds crazy, but there's a lot of these that do this. So these chemical messengers are important for roles in blood pressure, in your stomach function, in your immune system, right? It happens. There are autocrines. They stimulate themselves, right? We've got paracrines up here, short distances, right to the cell next, to an adjacent cell. Then we have autocrines closer than an adjacent cell is yourself. Okay, now, so we have 3. Let's compare and contrast. We have autocrine to itself, auto, to itself, but you still got to have the receptor on yourself, right? That's targets the same. Paracrine to the guy next to you, right? And endocrine, this is in the blood vessel and it goes and finds the receptor in something else. This is an important picture for your head. If you don't understand it, go back and review. Okay, we're going to stop there and then we're going to do endocrine